6.1.
Review of trigonometry.
So let's recall the definition of the trigonometric functions. Suppose you have a coordinate axis, x and y, point P with coordinate x and y. Of course, you can parameterize this point by two coordinates, coordinate x and coordinate y. And of course, that will be unique way. So for each x, y, you will get only one point P. But also you can parameterize it by the angle, theta, and the radius from the origin, or the distance from the origin. So what I'm saying, let's connect our point P with the origin. And let's measure this distance and call it r. And also I will measure the corresponding angle, and I will measure it counterclockwise. And this will be my theta. So I'm saying that also this point can be obtained if you know two parameters, r and theta. That also gives you unique point P. And this is called polar coordinates. And so we'll define sine of theta, of this angle theta, as the y coordinate of my point divided by this radius r. And cosine of theta by x divided by r, and tangent of theta, okay, I usually write its tangent. Tangent of theta as y over x, or sine of theta over cosine of theta. And cotangent of theta by x over y, or cosine of theta divided by sine of theta. And two more, secant, which is r over x, or it is 1 over secant of theta. 1 over cosine of theta, and cosecant, cosecant, which is c as k of theta by r over y, or 1 over sine of theta. Usually, you can define this thing on just the unit circle. So if it's 1, this is 1, then you have some point on a circle that corresponds to some angle theta. Then, say sine of theta, by the definition it is y over r, but our radius is 1 since it's a unit circle. So sine of theta will be just y coordinate. And the same story happens with the cosine. So your x coordinate, so cosine of theta is x over r. So radius is 1. And that means that it's just x coordinate of your point. So I think this is kind of the best way, but here's the connection with two definitions. Another way to define the trigonometric function is to use the right triangles. So suppose you have right triangle ABC and some angle theta, and then you say that sine of theta is equal to CB over AC. Or if you denote these sides as x, y, and z, then it will be y over z. How to connect it with the previous? You just make the origin at point A. So create this axis. And so your point C has coordinates x and y. And again, that will coincide with the definition, with the first definition. Maybe some tricky stuff to calculate cosine of cosine of 300 degrees. How you can do that? First, if we consider the 300 degrees, it will be somewhere here. And in other words, I can say that this angle is 60 degrees. But then you just need to consider some triangle that has, and again, say I have point P here with coordinates x and y. And so by the definition, the cosine of 300 degrees is equal to, so this is r, is equal to x over r, where x is the coordinate of my point P. Okay, let's call it star to distinguish from capital X. So what I need to do, I need just to find nice triangle, right triangle that has 60 degrees. Turns out that such triangle exists, of course, and this triangle has sides 1, 2, and minus square root of 3. Cosine of 300 degrees, if I zoom this triangle, here's my point P, here, this is my region. Cosine of 300 degrees thus will be 1 over 2. And the same story with all other angles and functions. What is more important and what we will use later is radian measure. So we have pi radian corresponds to 180 degrees. From here, you can find what is pi over 2 corresponds to 90 degrees. Pi over 3 corresponds to, so it's 180 divided by 3, which is 60 degrees, and so on. And some nice, let me write some nice angles like pi over 4, which is 45, and pi over 6, which is 30 degrees. And also from here, you can find that 1 radian corresponds to 180 degrees over pi, which is something like 57.3 degrees. And vice versa, 1 degree is pi over 180 and approximately 0.01745 radians. Why it's useful? Because in radians, you have nice formula for the arc length of a circle. Suppose you have some circle and you have some arc. Then this arc, there is a connection between the length of the arc, which I will denote by S, and the angle theta that measured in radians. And S is equal to R times theta. So the radius of the circle times theta, where theta measured in radians. So for example, length. So suppose you have half circle with radius R, then the corresponding length will be radius R times, so this is 180 degrees. What 180 degrees corresponds to pi. So pi times R. And also area of the circular sector can be easily calculated. You can calculate the area of the sector. Suppose this is alpha. Area, circular sector, will be 1/2 r squared times theta. And again, it coincides with the formula for the area of the whole circle, because whole circle corresponds to 360 degrees. That corresponds to 2 pi. So area thus will be 1/2 r squared times 2 pi, or pi r squared. That's how you can check it. A few words about the graphs. First of all, you see that your function is, say, if you consider y is equal to sine of x, your function is periodic. With period 2 pi. So what does it mean? That means that y of x plus 2 pi is the same as y of x. Or in other words, sine of x plus 2 pi is equal to sine of x. So also tangent, cotangent, cosine, cosecant, secant are also periodic function with period 2 pi. If you consider just sine of x, then the graph, so it's enough to draw it on the interval from 0 to 2 pi because it's periodic, and then we just repeat the picture. At 0 it's 0, at pi over 2 it is equal to 1. That's what you can see. Again, the easiest way for me at least is to use unit circle and see what happens with y coordinate of the point when you change the angle. So it's 0, 1, then it comes to 0 again, then it comes to -1, and then it comes to 0. So here is -1, here is 1, and so your graph looks like this. And then it repeats like that, and then it repeats here as well, and so on. And if you consider a slightly different function, a is equal to sine of bx, then you have some changes. First of all, period. Now it's not just 2 pi, but it becomes 2 pi over b. And amplitude also. Amplitude changed from 1 to a. Amplitude is the value of maximum of your function. So you see that your sine is between -1 and 1. Yes, for example, y is equal to 3 sine of 2x. And then what happens? First of all, your amplitude is 3, so it will run from -3 to 3. And also your period is changed, so now your period is pi. So it's 2 pi, and this 2 is here, so that gives you pi. And so that means that your graph is squeezed. So now you have now it will look like this. First of all, you see that amplitude, this is amplitude, is increasing while the period, which is the distance between two peaks, period, now is smaller. Instead of 2 pi, it becomes pi. And similar stuff with the cosine, but cosine starts from 1, then goes to 0. So for cosine, the graph is like that. And similar story with the period and amplitude. What you should remember. First, the most important one is the trigonometric identities, and the general one is, of course, this trigonometric identity. The sum of cosine squared and sine squared is equal to 1. And from here, for example, if you divide by cosine squared, what you'll get? You'll get sine squared of x divided by cosine squared of x plus 1 is equal to 1 over cosine squared of x. But this is the same as sine of x divided by cosine of x squared, which is tangent of x squared. And so you get another identity that 1 plus tangent of x squared is equal to 1 over cosine squared of x. In a similar way, if you divide by sine square of x, then you'll get that 1 plus cotangent of x squared is equal to 1 over sine squared of x. The sum and difference identities. That's sine of alpha and beta is equal to sine of first one times cosine of second one plus minus cosine of the first one times sine of the second one. So they switched in some sense. While cosine of alpha plus minus beta is equal to cosine of alpha cosine of beta minus plus sine of alpha sine of beta. And from here, you have many interesting corollaries. First of all, sine of double angle. So it is the same as sine of theta plus theta. And you can use the formula of the sum. Will give you what? Sine of theta times cosine of theta plus sine of theta cosine of theta. No surprises. So sine of 2 theta thus will be 2 sine of theta cosine of theta. The same story with the cosine of double angle. If you just plug, it will be cosine of theta minus sine of theta sine of theta, or cosine squared of theta minus sine square of theta. Or you can use the trigonometric identity and write it as 2 cosine squared of theta minus 1, or 1 minus 2 sine squared of theta. And also, you can see the connection between sine and cosine. For example, sine of alpha plus pi over 2 will be sine of alpha cosine of pi over 2 plus, plus minus even, plus sine over pi over 2 cosine of alpha. But the point is that cosine of pi over 2 is equal to 0. And so the first term disappeared, and you get that sine of alpha plus minus pi over 2 is equal to plus minus cosine of alpha. And yes, sine of pi over 2 is equal to 1. So this is the connection between sine and cosine. And sometimes, and in fact, we will use it in the next lecture. And the last formulas, using this formula for cosine of double angle cosine of 2 theta is equal to cosine squared of, say, this. From here, you can express 2 cosine squared of theta is equal to cosine of 2 theta plus 1. So cosine of squared of theta is equal to cosine of 2 theta plus 1 over 2. And thus, cosine of theta is equal to plus minus square root of 1 plus cosine of 2 theta over 2. Or if you plug instead of theta divided by 2, you will get cosine of theta over 2 is equal to plus minus 1 plus cosine of theta over 2. And this is called half angle identities. This is for cosine, but the same story you can write that cosine of 2 theta is equal to 1 minus 2 sine of square root of theta. And so 2 sine square root of theta is equal to 1 minus cosine of 2 theta divided, okay, not divided by 2, but if I erase it, divide by 2, and so sine of square root of theta is equal to 1 minus cosine of 2 theta divided by 2. And thus, by the same reason, sine of theta over 2 will be plus minus square root of minus cosine of theta divided by 2.